Hello everyone, welcome to Physics Academy. This is our Jest 2024 PIQ series part 6 of part B 3 marks questions. Okay, in the previous lectures from part 1 to part 5, I will discuss the 1 marks 25 questions and also 3 marks 10 questions. Okay, so in this video I will discuss the remaining 5 questions for part B 3 marks questions MSQ. Okay, and the next video I will discuss the last 10 3 marks questions for NET type questions. Okay, so let's start our video. Okay, this is the question number 11. Okay, question number 11. So what is the questions actually? Two trains each having proper length L0 are moving towards each other with the same speed v but in the opposite directions as measured by an observer in an inertial frame. Okay, what is the length of one of the trains? What is the length of one of the trains as measured by the observer in other trains? Okay, actually there are two trains. Okay, one train's moving with velocity v, another train moving with velocity v in opposite directions. Okay, so we are trying to calculate the what is the length of one of the trains. Two trains having actually same length, two trains having same length. Okay, these trains having initial length, proper length is actually L0. These trains having initial length or proper length is L0. Okay, and these two trains are actually moving in towards each other with velocity v. So we are trying to calculate the what is the length of one of the trains as measured from the observer in others frame. Okay, so here to calculate the length of the one of the trains by other observer in other who is actually sitting in other trains, first of all we calculate the relative velocity between these two trains or between these two frames. Okay, here actually two frames are actually moving one each other's, right? So what is the relative velocity? So relative velocity, we know the formula of relative velocity, that is from velocity addition theorem, that is equals to v plus v. That is we are already know velocity of two frame, velocity of two object actually. So v plus v plus 1 plus v square upon c. Here plus is actually from these two trains are actually moving in opposite directions. So we know the relative velocity is actually 2v upon v square 1 plus v square by c square. This is the relative velocity with these two trains are actually moving. Now we calculate the length contractions. The length of an object moving with a speed v real as seen in another frame is given by the Lorentz contraction formula, that is the length contractions formula, that is equals to L0 L0 L equals to L0 root under 1 minus v relative velocity square upon c square, and we here substitute the value of relative velocity and we get finally the finally result 1 minus 4 into v square plus c square upon 1 minus v square by c square whole square. So that is equals to 1 minus v square by c square whole square upon 1 plus v square by c square whole square. So that is equals to L0 1 minus v square by c square upon 1 plus v square by c square. So that is very easy problems in the Jest examination, and that is this questions asked in your exam for 3 marks. This is the very easy questions. Okay, so this type of questions is very important for Jest examinations. Two frames actually, this is the one frame, it is moving with velocity v1. This is the another frame moving with velocity v2, and one observer is present in this frame, and we are trying to calculate what is the length of these trains what is the length of these trains, or what is the length of an any kind of object are actually present in the S1 frame. Okay, this is the S1 frame, this is the S2 frame. So for this type of questions we are trying to calculate. First of all, we calculate the relative velocity. Okay, relative velocity, that is equals to v1 plus v2. Okay, 1 plus 1 plus 1 plus 1 plus v1 upon c square. This is the formula actually for velocity addition theorem. From velocity addition theorem. Okay, so we just type this type of formula for in relativity case. So okay, so next we go to the another question, that is question number 12. That is very important questions. An infinitely long cylinder of radius r has a uniform volume charge density. Okay, has a uniform volume charge density, and a spherical region of radius capital R is curved out of it as shown in the figure. At what value of R the radial coordinate in the cylindrical coordinate system with origin at the center of the sphere is the electric field is maximum. So here given actually this is the cylinder. Okay, this is the cylinder, and from this cylinder we are curved out a sphere. This is the sphere, it's have a radius r, and this is the cylinder, it's a radius r also. Okay, and this cylinder have a uniform volume charge density. We are consider the volume charge density is actually rho. We are when this cylinder have a uniform volume charge density. Now from this cylinder we are curved out a spherical regions of radius r. Then what is the charge density of this spherical regions? The spherical regions have a charge density minus rho. Okay, this spherical regions have a charge density minus rho. So for overall, before curve out, after curved out the spherical regions from this cylinder, the overall volume charge density is actually rho. And when curved out or cut out a spherical regions from this cylinder, then what is the volume charge density of this sphere is actually minus rho. Okay, this is we get from this is we get from the electrostatics equivalence principle, method of equivalence principle. Okay, so let rho is the uniform charge density of the cylinder, minus rho is the charge density of the missing sphere, and it is we get from the method of electrostatics equivalence, where the removing charges from a region is equivalent to the adding an opposite charge distribution. This is the method of electrostatics equivalence. What is the method of electrostatics equivalent? Where when a charge is removing from a regions is equivalent to adding an opposite charge distributions. Okay, this is the method of equivalence. Now the electric field electric field of the full cylinder, actually when we are not carved out the sphere, then electric field inside an infinitely long uniformly charged cylinder at a radial distance r less than the r cylinder, that is equals to r less than r. Okay, that is equals to E cylinder is equals to rho r by 2 epsilon naught. We are already know the formula. Again, the electric field due to the missing spherical regions, so when a spherical cavity is cut out from this cylinder, we can replace it with a sphere of charge density minus rho from the method of equivalence, and which create an additional electric field inside the cavity. Okay, and so the electric field inside the cavity due to this missing sphere is equals to minus rho f by 3 epsilon naught. We are already know for a sphere uniformly charged sphere at a inside point, for a uniformly charged sphere uniformly charged sphere, and we are trying to calculate the electric field at a inside point, that is equals to minus rho r by 3 epsilon naught. That these are the two formula you already know. Okay, so now the net electric field inside the cavity. What is the net electric field inside the cavity? Electric field due to cylinder, electric field due to cavity at a inside point r, that is equals to rho r by 2 epsilon naught, that is equals to minus rho r by 3 epsilon naught, that is equals to rho r by 6 epsilon naught. Okay, so we get the net electric field inside the cylinder, or inside the cylinder is directly proportional to the r, small r, radial distance, right? So that's the electric field inside the cavity. That's the electric field inside the cavity is maximum at r equals to r. It's so obvious. And also outside the cavity is maximum 3 r over. This is from option. So in the questions we have two we have two answers actually already mentioned in your questions. Due to the possible alternate interpretations, it means if we calculate the electric field maximum at outside point or electric field maximum at inside point, then we get two answers actually. So they are not mentioned the where the electric field is actually maximum, inside or outside. They are just asked what at what distance, at what value of r the electric field is maximum. Okay, so this is the actually confusing questions they ask actually. The confusing question they ask. So students are confused where at what point we calculate the electric field, maximum electric field, inside or outside. So for outside electric field maximum at r equals to 4r by 3. This is for outside. Okay, and this is for inside. That's why option A and options B will be treated as a correct answer. Don't worry. Okay, very good. Next we go to the next question. Okay, question number 13 is actually wrong questions. Question number 13 is a wrong questions. This question is withdrawn since the label are not shown in the figure. All candidate will be awarded 3 marks questions. So this is actually wrong questions. Don't worry. सारे क्वेश्चन स्टूडेंट को एक्चुअली बोनस मिला था, ठीक है, सारे स्टूडेंट को एक्चुअली बोनस मार्क्स मिला था इस पर्टिकुलर क्वेश्चंस में से, सबको मिल गया था +3 मार्क्स क्वेश्चंस सबको मिल गया था, राइट, +3 मार्क्स एक्चुअली सबको मिल गया था, है ना। तो वो अगर इसी तरह जिसमें ऐसा होता है एक्चुअली एक ना एक क्वेश्चन एक्चुअली क्या होता है ऐसा वो लोग रॉन्ग क्वेश्चन दे मेंशन एक्चुअली रॉन्ग क्वेश्चन दे गिव फॉर 1 मार्क्स और 3 मार्क्स any kinds of marks they actually give that kind of questions, okay, in your examinations. So okay, this is the wrong questions actually. So now we next go to the question number 14. That is very important questions. We here use a very beautiful mathematical approach to solve this type of questions. Okay, so what is the value of these integrations? So integration is equals to 0 to infinity dx upon 1 plus x cube. Most of the time this type of questions we calculate using the complex analysis method, but in this case, but today we use beta functions. Okay, definitely this type of questions when they ask 0 to infinity dx 1 plus x to the power 6, 0 to infinity dx 1 plus x square, 0 to infinity dx 1 plus x cube, this type of question they ask in your examinations, then you definitely use the beta functions. Okay, definitely use beta functions. Otherwise you use or complex analysis method, residue calculations, but here we use the beta function method not complex analysis method. This is actually long approach for solving this type of question. Okay, so let us take x equals to u to the power 1 upon 3, because x equals to, where this x cube is given, is x square given, we take u to the power half. Is x to the power 6 given, we use x to the power x equals to u to the power 6, etc, etc. Okay, so dx equals to 1 upon 3 u to the power 2 by 3 into du. We just substitute it, integration limit always 0 to infinity, so that is equals to 1 upon 3 u to the power 2 by 3 1 plus u. Okay, so finally we get 1 upon 3 0 to infinity u to the power 2 by 3 du upon 1 plus u. So this is the this is the actual mathematical expression of beta functions. So what is the expression of beta functions? 0 to infinity x to the power m minus 1 1 plus x to the power n dx equals to, this is the standard mathematical expressions. Please remember the beta functions representations. X to the power m minus 1 1 plus x to the power n dx is equals to pi to the pi upon n cos m pi upon n. Okay, so this is the m pi upon n. This is the mathematical approximations. Please remember, okay. So here u to the power minus 2 by 3, that is equals to u to the power 1 upon 3 minus 1, that is equals to 1 upon 3 minus 1. So m is equals to 1 upon 3 and 1 plus u, that is equals to n equals to 1. So m equals to 1 upon 3, n equals to 1 from these expressions. So we just substitute this mathematical formula, m and n value. So m upon 1 pi upon 1 cos m pi upon n equals to 1, so cos pi by 3, so that is equals to pi by 3 cos pi by 3, so pi by 3 cos pi by 3 is equals to 2 upon root 3. So finally we get 2 pi upon 3 root 3. So option A is the correct answer. Okay, so always this type of questions you calculate using beta function approximation, beta function representations. Okay, next question number 15. Now it is very easy questions from OPAM. Every year they ask from 1 questions or 2 questions from OPAM. Okay, so what is the output voltage? So what is the output voltage V0 and current in 10 ohm resistance of the following circuit if input voltage is equals to 0.5 volt? So this is the non-inverting amplifier. Non-inverting amplifier. So for non-inverting amplifier we get the output voltage is equals to RF upon RI. Okay, so we use this formula and we get 1 upon minus 1.25 volt output voltage, and they ask current from 10 ohm resistance. We use the virtual ground concept. So from virtual ground concept, at that point the voltage is actually 0. So virtual ground concept, we apply in this loop, we apply KVL. So we get current I equals to VI minus V0 upon RI. So that is equals to 10 minus 0 upon not 10 that is equals to 0.5 volt. 0.5 volt minus 10 kilo ohm, so that is equals to 0.5 upon 10 kilo ohm. So that is actually 50 microampere. Okay, this is equal 50 microampere. So from this question, option A is the correct answer. So this question is very easy questions they ask actually. Okay, so next video we are deal with part C, 3 marks question, that is basically NAT type question. They ask 10 NAT type questions. We must discuss all the questions in detail like the previous videos. ओके पिछले जो जैसा वीडियोस था सारे वीडियोस के जैसे हम लोग डिटेल्स 1 by 1 एक एक क्वेश्चंस को हम लोग डिस्कस करने वाले हैं, ठीक है। और ये जो वीडियोस था इस वीडियोस में हम लोग पार्ट ए और पार्ट बी को कंप्लीट किया। लगभग हम लोग 25 + 15 मतलब हम लोग 40 क्वेश्चंस हम लोग सॉल्व कर दिया, ठीक है। वी आर एक्चुअली सॉल्व 40 क्वेश्चंस फ्रॉम दिस Jest 2024 previous PIQ question paper. So I think these videos are very helpful for your upcoming Jest examination in 6th April. Okay, 6th April. So please stay with my channel and subscribe my channels. Okay, thank you for watching this video.